we are going to discuss about the DT based discussion on low power VLSI in ECG signal noise reduction process. Okay. What all are the 5 stages of the design
thinking? To explain about the design thinking concept, it is nothing but the problem solving approach, that is how to solve a problem using 5 steps. So the 5 steps are involved in this design thinking concept is empathy, define, ideate, prototype and testing, and evolving also. So in empathy part, we should know what is the customer's perspective and what are the problems they are facing in their day-to-day life. So in the define part, we should take among a best problem to notify and to get into the customer. And in ideate part, we should give some ideas and prefer some ideas to work on it. And in prototyping and testing, we should make it true in a live sample and to implement in testing part. So the empathy part will be explained by the teammate.
Yeah, coming to the empathy part, empathy is nothing but the feeling from the customer's perspective. In this VLSI low power design, the end users and customers are the patients. Patients are using the wearable devices and health monitoring devices, and not only patient, doctors also comes under these. When doctors are monitoring the patients from the portable health devices, and it is also used for the continuous monitoring without frequent charging, because it is a portable health devices, and it does not have delay detection, and it should be comfortable for the patients and for the doctors too, and should be lightweight and wearable devices. It should give the reliable time detection and results.
Okay. Next, to come to the design part, nothing but it is the framing the problem. How might we design a low power and ECG real-time ECG processor that accurately filter and detect the ECG signals, and then runs on minimal power for extended battery life, and is compact enough to integrate the wearable or portable devices.
Then coming to ideate part, how we can addressing the problems to the ideate. Now the ECG signals was converted into digital to analog, and then adaptive filters are used in the ECG conversions, then employed the event driven to improve the performance of the chips, and then using of clock events for the communications, then FGBA prototype for early stage of testing, and then moves to ASICA.
And we are also using the use clock gains gating and data path optimization to save the power also, and then employ the event drive architecture also.
And next, a prototype. In prototype, each signal modulations is converted into an analog signal into digital signals, and we have used in some of the filters in it. We have it's to convert noise reducing filters using in ECGs, and we are using signal monitoring device. We have used output module. It will give a signal or digital wave in our monitor or any other things. Can light or wave, it converted into some of the simulations, MATLAB, or in VLSI field we are using Cadence, Xilinx, and many other tools we have used to simulate the waves are converted into many other signals. We converted a ECG into a prototype or any other model. First of all, it implemented into implementing human. It will implement in some other animals or monkey, anything. First of all, it will more accuracy, and to check a human animal. First of all, animal heart or heartbeat, anything. First of all, check to animals, and next it converted into humans to checking all of the
hospitals.
Yes.
Research.
We check the clock speed as 10 to 50. It said. In real time, we simulate with ECGs and verify the noise and heartbeat detections, and FIGP in the loop for whole simulations. In accuracy, it has 95% accuracy in RPEAK and in VH database. In latency, it has 100%, and in area utilization, the minimum gate count on sharings and pipelines.
Okay, so to conclude this session, we have noted what what are the 5 stages in design thinking part, and each one have a knowledge about in VLSI. So explained with a project which is in ECG. So this is the part where VLSI plays a major role in everything. Thank you.